Okay, peek at number 12, again with great background noise with my youngest boy is behind me. But first thing you got to do is what we're talking about, finding derivatives so we can get critical values, and we're going to do intervals of increase and decrease. So it starts with the derivative. Here's h prime of x, and this one's a product rule, no doubt about it. You got to pull up, got to do all your parentheses, got to make it happen. And you do the derivative of the first times the second unchanged, so the cube root x minus 3. But when you take the derivative of that x minus 3 chunk that's right in here, you want to think of it as to the 1/3 power is important. So, hi Graham. Say excuse me.
What are you doing?
Did you say excuse me?
Can I sit by you?
Yeah, you can sit by me. Did you say excuse me?
Excuse me.
Okay.
Why are you coloring me?
Well, I'm making a little note for my students in their class, and now they're listening to you talk about making a note for the class. It's pretty fun, isn't it? Okay, so we're going to take a derivative, and when you do that, you all know the process. It's power out front, leave the inside untouched, reduce the power by 1, so it's negative 2/3, times the derivative of the inside. In this case, that is 1. So that derivative goes here in that first box there. So derivative of the first, I'm going to underline all these, times the second unchanged, plus the derivative of the second, which I just conducted, which I'm dealing with 1/3, and there's x minus 3, 2, now the negative 2/3, so it's getting kind of tiny, and then times the first unchanged at the end. Now, that is our derivative ready to be used. The first thing is I'm going to think about, hey, when's the derivative equal to 0? So I'll take this whole thing and simplify just the tiniest little bit. I'm going to say, here's my derivative, cube root of x minus 3, the first part, and plus, now, it looks like we've got a 1/3 x times, looks like x minus 3, to the 2/3, negative 2/3. And that ends up being our derivative that we set equal to 0. Now the thing that I've told you in class is that, hey, you know that negative exponent thing? We need to take care of that. We need to rewrite that so that it's in the denominator and to the positive 2/3. So what I'm going to do, we want to pause here for a second, I'm going to delete that and rewrite it the way we were talking about. Okay, so instead of how it's right now, delete, 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 delete. I need to make my eraser a little bit thicker here. It's going to take a while. But now you put the x on top, keep it on top that was there, and on the bottom we're going to put that x minus 3 to the 2/3, and that's the first step. So we always want to take care of those negative exponents as such and put them in this regard. Okay, that's a little sloppy, but the next step is you want to get that fractional chunk on the right hand side. So we're going to get the cube root of x minus 3. Do you want to say hi, Ethan? You say hi to my class?
Hi.
There you go. And then you get negative 1/3, well, it's actually negative x over, can you kind of see where this is coming from? 3 times x minus 3 to the 2/3. Okay, that's the first part of solving that. And then do you remember we multiply both sides by the denominator? And so if I take the denominator, I'm going to change my color up a little bit. There we go. And multiply both sides by 3 times the x minus 3 to the 2/3. Graham, we can help you. Just use your words, buddy. And then, okay, we'll help you.
I'm gonna come.
Here comes Ethan. X minus 3 to the 2/3. Okay, so that's what we multiply on both sides of the denominator to cancel on the right. And then on the left there we have that product. And so we're going to go ahead and take, I'm kind of running out of room here, but I have just a wee bit of room on the right hand side there to kind of finish this chunk off. So I'm going to fit it in there. So here's, you kind of keep an eye on it. We have 3 times x minus 3 to the 2/3. And it's times it's the cube root of x minus 3. Well, the cube root of x minus 3, it's time that we kind of know how to rewrite that, because this right here, see how that cube root of x minus 3, I'm going to rewrite it over here in its proper form for combining these things, and I'm going to put it x minus 3 to the 1/3. It's equivalent to the cube root, equal to negative x. Okay, so that cleans things up a little bit, but it sets us up for the important next part. These are the same base, which means we can do the exponent rule where we can combine them as a single x minus 3 and just add the exponents that they have, their respective exponents. And if you do 2/3 plus 1/3, you get 1. So
Down.
here we are sitting at 3 times x minus 3 minus or equals negative x. And we're in the home stretch here. Distribute the 3. Okay, and then we get 3x minus 9 equals negative x. Sorry, it's getting a little tight over there. Add the x to both sides. You get 4x minus 9 equals 0. And then you can subtract 9, or add 9 to both sides. And then finally x is 9/4. That is our first critical value at 9/4 for that particular function. Now that's only part of it. Remember, critical values also require where it's undefined, so we'll do one more piece to this. So I'm going to add a page to my little document here, and you kind of can't see what I'm doing there, but what I need to do is figure out where is my derivative undefined. And where my derivative, f prime, is undefined from the previous page. So if I go back and show you that real fast, undefined is wherever I have a denominator, and let's put it in some crazy color, I don't know, green or something. Yeah, hang on a second, buddy, we'll get it. Okay, so maybe... Sure, bud.
Okay.
I'm sorry for the little pause there, had to help out somebody's putting on their bumblebee costume. But see that denominator I just highlighted? That's the only denominator in our derivative. That's the part we have to set equal to 0. So on that next page, if I jump over, we need to write that denominator out, which currently rests as, was it 3 times x minus 3 to the 2/3 was our denominator in our derivative on the other side, the only one we had. We set that equal to 0 because that's the issue. We need to know when that denominator will be 0 because that's a possible critical value. It's something of interest. We can actually stop here. You can either algebraically solve for or recognize, man, this thing's going to be 0 as soon as x minus 3 is equal to 0. I put in a 3. 3 minus 3 is 0. 0 so that any power times anything is just going to be 0. So I think it behooves us to recognize that, hey, it's going to be 3. That's one of our other critical values. It's what causes our one denominator in the derivative to be 0. So it's a critical value. So we have 2 critical values. So go back to the other one. Remember, didn't we come up with one from setting the derivative equal to 0 gave us 9/4, and from setting finding where the derivative is undefined gave us 3. So we have 2 critical values. Now, if you're taking a peek at the graph, which I'm going to draw a quick sketch of, I'm just going to do my favorite calculator, and I'm going to get a little sketch going. I'm going to look at those critical values and then talk about those intervals of increase and decrease then around those critical values, and that's the next piece. Okay, so here's a quick little sketch. Pardon any breakdowns you hear in the background, we're almost to the end of this. But if you look at the quick sketch of the graph, we're going to find the critical values are right here. Here's 9/4. That's where that peak occurs. That's because when we set the derivative equal to 0. So yeah, there's a horizontal tangent there. And the other one is right here. It happened at 3, didn't it? And that's a weird critical value. It's actually a place where you get a vertical tangent. And that's actually when the derivative is undefined at a vertical tangent. So it makes sense. They're interesting places. That means things likely happen. So in those spots. So here's how we're going to frame these intervals of increase and decrease. It looks like if you guys take a peek at this, I'm going to try and get some other colors. It is definitely going downhill all the way. If I get my marker to work. Oh, can't get it to right. All the way down here to that critical value. So negative infinity to 9/4 is decrease. Sure. So negative infinity definitely to the 9/4 mark is downhill. It's our only downhill stretch. The uphill stretches are from 9/4 on up. Now, some textbooks want you to put that critical value 3 in there, but I believe WebAssign is just happy to have you say it's going uphill anytime after 9/4. And if you want that marked in some color here, let me get a color going for you. Let's do blue on this side. That whole region on the right-hand side is uphill. Hope that helps. Get you the stuff you need. Let me know if you need more.